Welcome to a lesson with Dr. Powell. Let's take a look at how a function can behave on sets, not just elements, but whole sets in the domain. A function f can actually take a whole set in the domain and cast it to or send it to a set in the codomain. It's going to be the image of the set in the domain. So how does that work? Well, you just kind of take all the points in whatever subset we take of the domain, and we run them through the function, and we take all the outputs that we get from these ones, and that's where we go. That's going to be the image. So we can go from a subset in the domain and get out a subset of the codomain. We can also work backwards. What if we take a subset of the codomain? We can our function can actually tell us or give us a subset of the domain simply by just taking those 2 points and following all arrows that go backwards from them and getting all those all these points here that are the beginning of the routes, and that represents what we call the pre-image of the set B. So you take any subset of the codomain and it has a pre-image, and this is what it would be. Okay, now notice something right here. Let's take different subsets of the codomain, this one and this one and this one, and let's look at their pre-images here and here, and the pre-image of 7 is just empty. So notice that these guys are disjoint, meaning that they have trivial intersection. If you try to intersect this with this, it'd be the empty set, or this with this would be the empty set. And that happens from looking in the codomain. These guys have empty intersection, right? And as we go backwards, they're going to have empty intersection because something that all the things that go to 8, everything that goes to 8 is not going to go to 6. Everything that goes to 6 is not going to go to 8, and vice versa, because the way a function is defined is everything in here only has one place to go. And that's what makes it a function. Okay, so let's look at preimages of just singleton sets, meaning elements or sets that just have one thing in them. So we can do that. We can cast them back. And notice that these guys are going to be disjoint as well. 7 has an empty preimage. Now, these preimages right here, the preimages of singleton sets, are called fibers. Now, we can represent our function in another way, the same function, by putting boxes down and labeling these things. Well, what are this? Let's see, this is 6, 7, 8, 9. Let's look back here. 6, 7, 8, 9. That's the codomain. So right here, you see the codomain elements. Now, what are these guys? 5, 6, 1, 3, 4, and 2. Those are the domain elements. Notice that the domain elements only happen once. And also notice, you see these circles right here? We can actually link those circles with boxes. So, for instance, we have actually this 1 and this 3, 4 right here. Actually, those go together. Those are parts of the preimage of 8, 1, 3, and 4. And notice there's a box, 1, 3, and 4, and it lies over 8. This is called the fiber over 8 for the function f. It's simply the preimage of 8. So the boxes are just preimages. So this element's in the codomain, its preimage is 2. Let's see. 9, its preimage is 2, right there. Okay, right here, 1, 3, 4, that's the preimage of 8. Let's check it. 1, 3, 4, that's the preimage of 8. This is called a fiber box diagram. What's the preimage of 7? Nothing, just as we expected. 7 doesn't go back anywhere. What's the preimage of 6? 5, 6. Right here, preimage is 5, 6. So this is what we call a fiber box diagram. It completely describes what's happening with the function. It's another way of thinking about it, and it kind of categorizes things or puts things into into boxes, into fibers. The basic building blocks of the function are right here, quite literally looking like boxes. Now, here's some examples of some other functions completely written with fiber box diagrams, but it completely describes the function because in the fiber box diagram, you can actually see what the codomain is, and you can see what the domain is. Now, this particular function, notice that no box has more than one element. If that's the case, then the function is what we call injective. So a function is injective if there's at most one thing that goes to a codomain element. So you're not going to have two things running to the same place. That's what injective means. No two things run to the same place. Now, this one right here, notice that you don't have any empty boxes. That's called a surjective function. No empty boxes. So this one, injective, just simply means no box has more than one. Surjective means that you don't have any empties. Now, this last one, notice it has no empties, and every box has one element in it. So, in other words, it's both injective and surjective. In that case, we call it bijective. Thanks for watching.